So it turns out I have one more example from this set before we move on within these sections. Part F is the limit of the sine of x over x as x approaches 0. And now if you thought of the last one or the last few have given us some problems, oh, we're going to encounter something else here. So we think, okay, hey, how do we begin any of these, right? Well, we always just try to plug the number in. And then we kind of see what that tells us, and we go from there. If we can plug the number in and it gives us an answer, then we say, great, we got it. But if it gives us, 0 over 0 or some other things, then we know we've got some other work to do. And that's the case here, right? So if I try to plug in the 0, sine of 0 over 0. Do you guys remember what the sine of 0 equals? If you remember your trig, the sine of 0 is 0. If you don't remember that, well, that's what calculators are for. But hopefully you remember that. The sine of 0 is 0. Okay, so again, we know we've got a hole. So you think, all right, so what's the approach then? Right, if you've got a hole, so we've seen factoring, where we're able to cancel out the pesky term in the denominator. In the last problem, we multiplied the top and the bottom by the conjugate. Well, this one is a very different story. The sine of x over x. There's no algebra that we can do to this. There's no factoring. There's no conjugate. There's nothing we can do to top and bottom or anything else to cancel out that x. There's no way to simplify. We cannot simplify that anymore, certainly. And so this gives us another approach to finding a limit just depending on what presents itself. If there's no way to simplify, then we're going to use a table. Okay, use a table of x values approaching x equals 0. So what does that mean? What does that look like? Okay, so here we go. We're going to create a table for the left side of 0 and a table for the right side of 0 for values of x approaching 0. Let me begin by explaining what I've got here on the left. So on the left side of 0, of course, we're into the negative numbers. And so I'm going to pick a few negative numbers, but those negative numbers approach 0, right? So negative 0.1, maybe that's a good go-to place to start at 0.1 away. Then we're going to approach 0. So then we're going to move to negative 0.01. So we're getting closer. And then we're going to move to negative 0.001, getting even closer. So we're moving in, right? Picture that arrow from the first examples we did. We're moving closer to 0 on the left side. Same idea on the right side. We're moving closer to 0, but now we've got the positive versions, 0.1, 0.01, 0.001. So we start a little bit to the right, and then we pull it back in close. At this point, grab a calculator. I've got mine here. I'll just kind of put mine right there. And I'm going to calculate the values of sine x over x for each of these. And we're going to see how it's moving as we approach 0. So I don't know how well this is going to show up. Be sure you're in radians. These are all radians. They're not degrees. Okay. So I'm in radians. I don't know if you can see that. If you're using a TI, it's under mode. You can switch degrees as the default, but you can switch over to radians there. Okay. So we've got the sine of negative 0.1 over negative 0.1. What do we get? And that's kind of tough to see. I don't know if it's coming in any better for you guys than it is for me looking at the screen. I'm going to go ahead and take that to 6 decimal places because I've done this problem before. 0.9983334. 0.998334 when I round it. Okay. So there it is at negative 0.1. How about negative 0.01? Sine negative 0.01 divided by negative 0.01. What's that going to give me? Okay, another 6 decimal places again would be 0.999983. Okay, so again, we're kind of thinking about how it's moving. What is it approaching? Let's try this last one. I think we'll have a very good idea. The sine of negative 0.001 divided by negative 0.001. And all right, if I go to 6 decimal places again, it's all 9s. And I think, we can see what's happening. Like the 9s are growing. It goes from 2 to 4 to 6, right? Okay. So maybe this gives us a good idea of what it's approaching, but we need to make sure that it's the same on the right side as well. The positive versions, so sine 0.1 divided by 0.1. And what do you know? I actually got the same number. I slid it off the screen there, but it's the same number as the negatives. And is that going to be true for 0.01 also? It is 0.999983 and 0.001. And at that point, it's all 9s, 6 9s. And then it begins the 8-3 at that point. Okay, so let's kind of pull it back here. We're using a table. You think, okay, well, first off, does it appear to be approaching something that we can guess? And I think it does. And then, even more importantly, does the left and right sides, are they coming to the same, or do they agree? Are they coming to the same answer? And yeah, they are. I think we can say, and this would be better if we were in class, like, hey, what does it seem to be approaching, you guys? Both these numbers seem to be getting closer to 1. And so that turns out to be our answer right there. Using a table this time. Use a table. So we've got a new approach. So we saw factoring, we saw multiplying by the conjugate. The idea of the table, I just want to kind of tell you guys where it stands in the hierarchy of finding limits. It's a last resort. Let me just mention this here. Note, when there's a hole, a table is a last resort. Use only if no simplification is possible. All right, well, that was the case for us, sine x over x. But if it's possible to factor, if it's possible to use a conjugate, if it's possible to simplify in some other way, we need to do that. Why is this a last resort to use a table? Because the truth is, a couple reasons really. For one, it's just tedious. But even more so than it's tedious, a table needs to be a last resort because the truth is, we're actually just guessing when we say this equals 1. And it's true, it is equal to 1. But, when we see 0.99999, we're taking a really good guess that this thing is going to get to 1, as it approaches 0. And we don't know that, definitively like we did those other problems where we were able to simplify and then plug in and get that number that way. Then there's no question about it. This is only a really good guess, or a good guess at best. So tables are good. We're going to see them. There's times when tables, in other scenarios when tables are not a last resort, and they're not a guess. But in this case, when there's a hole, a table is a last resort. Only if you absolutely have to have it. Okay. Actually, I think that example took a while. I think I want to pause here and just keep that one example for this video. We're going to get into this one next.